Okay, let me start taping. Good morning or good afternoon, whatever time it may be right now. My name is Celso Battaglia, and I teach physics and astronomy at Evergreen Valley College, and I'm here representing a group of volunteers, faculties, and lab techs and students that organize themselves under this banner, Evergreen Valley College Citizen Science Initiatives. And what we do is to try to do science outside the classroom and engage students in the process of building up science. And we had a further motivation in doing that, and that is to reduce the gap, the achievement gap between underrepresented minorities and the top level in the STEM field, which is a PhD in any field. So since the field that we are more familiar and our community college has an observatory, so therefore the field we are focusing here is astronomy. But this is pretty much open to any other field. It could be biology, could be chemistry, could be um, computer sciences, could be space sciences, but we are focusing here in physics and astronomy so far. So the motivation is the statistics. So the percentage of female, the absolute number of female in percentage in the United States is still low. So 58% of males have PhD, in contrary to 42% of female. The numbers are even worse when we look at the Latino population or an African American population. Their numbers are extremely low when compared with their percentage in the population of the United States. So the target group that we want to work with is middle school. There are programs in place to help minorities in community college and in the university. The question is, when they get to that age, they might have decide that science is not for them and math sucks. They had some pitfalls while in middle school, um, and in high school to be a nerd is not something cool, and 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 to be in the STEM is not, in general, statistically speaking, is not the big plate for underrepresented. One that didn't have incentives to go to a museum, to be surrounded by technology, and or maybe having a family member that could serve as a role model in academia. So what we want to do is to not wait for community college or not wait for a freshman year in the university, but go straight to the middle school because that's the earliest we can achieve. And as much as possible to follow these kids through high school and through community college, or if they transfer directly, because we are establishing bridges with the local universities, San Jose State University and UC Santa Cruz, UC Berkeley, and establish bridges so these kids can be exposed to what is going on at the university level. But the main idea, if we could put together, is get the kids in the middle school and give incentives for them to be stuck to this program, follow them through high school. They complete high school also with a certificate of achievement that we are in the process of organizing and elaborate. And, and this certificate might give them a chance of a tech job if they choose to. But our goal is to bring them with that certificate with classes that can be used for the transfer goals, basically. And again, the main point we want to go, our utopia is to take them to the PhD level. And pretty much that gives the idea of what we want to do. Surround them with technology, opportunities for open-ended scientific research, and 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 the odds for these kids will be better. The philosophy that kind of guide us, we started kind of just talking with parents and talk among ourselves, but there are some good work out there that support of what we want to do, and I'm just bringing one of it from Melinda Karp. Create social relationship, clarify goals, and emphasize commitments. Familiarize with college environment and technology, integration with older peers and that will serve them as mentors. So let's take a look one at a time. So these kids will have constant contact with professors. So not only they will be meeting with us every week, in fact, we are meeting them now every Monday at 7 o'clock online, but they will be exposed to the academic language and to the rigor that we impose in our classes. They will be interact with citizen members of Evergreens Valley College CSI. If they wanna, when they become high school students, they can integrate the research we are currently doing. Um, Part of the funding of this project will come from the community, and we have the support of community activists. They are searching for money that will help to provide scholarships to the students. We are thinking about $500 a year in a college fund allocated to each one of the participant students. And once in high school, we have what we call advanced STEM lab, and there is one professor, in fact, a couple of professors in charge of these labs, and these students, if they choose to, they can either do research in astronomy or research in physics. What are the part B's for the students? Clarify goals and emphasize commitments. They have to maintain B grades or A grades. And I have my 7 minutes, so I have 5 more minutes to go in this presentation right now, so I have to shorten somehow. But so maintain B or A grades in math. They will receive $500 per year in scholarship if they participate regularly in our meetings. So they have to have 80% attendance. And at the end of 2.5 years, they will complete a course that we are developing step by step in astrophotography, and also a certificate of achievement in high school. And how about the item number 3, which is to become familiar with life? Well, they will be coming to our college. In fact, 3 of the meetings we had so far with the students was in the physics lab. They built up an optic bench. They play with lasers, and they saw how lasers work. They were all excited at creating images, and now they are learning how to do 2-star alignments with the telescope, and they are supposed to be helping us in stargazing events every month. But also we are planning on field trips to local observatory, to labs, and so on, so on, so on. Integration with older peers. So right now, our 2 high school students, they are not part of this process. They are not necessarily underrepresented minority. In fact, they are very well supported by their parents. They are good. They don't need this support. They are just there for enrichment. But we expect a few years from now, the middle schools we have, they will be high school students initiating research and helping out the middle schools that are entering the program. Our meetings are all done online, and here is our few examples. So in the left-hand side, those are meetings with the high school. So there are two meetings in there going on, and in the right-hand side is the meeting with the high school. So there's 2 different type of meetings. They are all on Monday. The middle schools goes from 7 to 7:30, 7:45, and so far we are just initiating. There is not a lot. I just need them to be consistent on time, and then at 8 o'clock we initiate our group study with high schools, and then take longer, go from 8 all the way to almost 9:30, 10 o'clock. Oops. Um, Now we got a partial, in fact, it's a grant that will help us over 2.5 years, and this grant is most of it is going to be used to pay the salaries of a lab tech that we need to be associated with this project, and also for our college, in fact, and those are the steps ahead. For the middle schools, they will be trained in two-star alignment, and they will be subjected to a curricula we are developing, and we are adapting existing curricula for these students. But the main point is towards the end of it, in 2.5 years, they will be able to take their own astronomical pictures and be proud of it. And by then they will know what a quasar is, or a galaxy, or planets, the difference between stars and binary systems, or Messier or nebula, or so on, so on, so on. And of course they have to maintain academic excellence. And I forgot to mention here, they will be coached by high school students, but right now we are partnering with the Learn to Be Foundation, which will provide at this moment the mentorship these middle school kids need in math. And we have few students that need that support, and we are trying to guide their parents to do the sign up, and so these kids can start to receive support. The high school, the project we are currently developing implies they need to understand what accretion in a young star is. They have to do some techniques in profile decomposition, which is technical stuff, and also to determine if there is some periodicity and some features associated with spectra. And for the community college students, what we have now is a physics lab, is an advanced STEM lab, and they are building up a cosmic ray detector. And how are we going to measure and see if they are doing what they're supposed to? Well, 80% of the the middle schools have to be present in 80% of our events. That involves volunteering stargaze. They have to show skills in astrophotography. Their grades have to be up, and they have to be there. And for that, they receive an incentive of scholarship. For the high schools, I mean, our limit, if we could call the star, is to have them being able to get together the data and do a presentation in a meeting of the Astronomical Society. Maybe, who knows, to write a paper, and for the community college students to build a new detector. I mean, those are the main issue. And how long did I take? I took I took 14 minutes, 13 minutes. So I have to reduce that further, but pretty much that's it.